Hi everyone, here is the EC504 final project, Video Encoder. We are Group 4. This project is to design and implement an efficient encoder of images into video, which is able to take an arbitrary number of JPEG files, encode them into one file, and play that file on demand. The encoder is able to encode hundreds of images into one encoded file in a second. User can adjust parameters on movie creation according to disk space or quality. Each image is compressed by pixels sampling, and then compress the new images with base 64 encoding schemes. Then it can play back the video from the encoded file. The video speed can be adjusted by different timer delay. To use the encoder, a command line, graphic user interface, and Android client are provided for encoding and viewing. Base64 is a group of similar binary-to-text encoding schemes that represent binary data in a string format by translating it into a radix 64 representation. And here's our demo.
Hello everyone, my name is Shenji, and here is our video encoder of PC Vision. And this is a folder containing 200 images. And now let me show you how to encode all these images into one file and then play it. So firstly, let's run a command line in Eclipse to implement video encoder. So just type encoder and file paths. Because typing in file path is time consuming, so we just choose 20 images here. And then type output and output path. So output and let's name it result 1. Okay, and this is our output folder. You can see it's empty now. So after running, we get a file named result 1. And then let me show you how to play it. So just change all of them to video. Okay. And you can see here, we provide 4 speeds here, 2 frames, 10 frames, 25 frames, and 100 frames per second. And I will show you this later, but we don't have enough frames now. So now let's try our GUI. And we provide 4 quantities here according to your disk space. We just choose 100% now. And then choose all of the 20 images here. And we have to wait several seconds. So it's still running. Okay, so just to save it as a file, let's name it result 2. And now play it. And now we can try different speeds. Let's try 2 images per second and turn and 25. And this is 100. Okay. So this is our demo. Thank you.
Here is our Android application. Here is our main activity. You can select the files, select the image files you want to compress and play. Here is a list of the image samples. You can select some of them manually and compress them. The path shows you the compressed video files, and you can when you click the display, it first extract the compressed file and play the extracted file. Also, you can select all of the images in this album and compress them all together. We compress a few hundreds of images within only a few seconds and display them. This is pretty cool. Thank you.
So for the design choice, each image is converted into a byte array and its size is recorded by the other byte array for size 4. Then they are combined into one byte array and written into a file using output string. Then they are converted to a string type and combined into a single encoded file. For viewing, after reading the file using input string, we get a byte array. Then read the first 4 bytes of that array to get the size of the first image, and read S bytes to store it as a buffer image. Then store all images using the same way. To play the video, we read the file and convert the string to image, store all images, and play it in GUI by repainting. We just simply start a timer to play each image. To adjust the video speed, different parameters can be passed into the function for different timer delay. Since JPEG image is well compressed, it's hard for us to compress it again. Therefore, we just use 2D space sampling to compress each image, which will cause some information loss in our case. For different qualities, we use different parameters to adjust the sampling space. For example, to get 25% quality, 1 pixel in every 2 pixels is chosen along the horizontal direction, as well as the vertical direction. For decoding, the missing pixels left before are predicted by calculating average value of its 4th click. Then the images are recovered by filling the missing pixels and play as a video.
Okay, so here is the some of the key points in our Android implementation. We are using a list view to display all images in the SD card so that the user can have a direct view of what they have chosen. So after the user chosen the pictures, then the activity will pass all the image paths in a string type array list to the next activity. And in the next activity, it will receive all the image path and translate it into a bitmap and compress it into test.comp. And so when the user hit the play button, it will read from the compressed file first and generate a bitmap type of array list and display it into image view. Great.
That's all. Thank you for watching.